Hello children, welcome to Yamuna's physics classes. Today we are here to discuss the topic radioactivity 13.6 in the lesson 13 nuclei. Now let us see what is radioactive decay. We know that an atom has a central part known as nucleus. In nucleus we have neutrons as well as protons, and these are of neutrons no charge, protons positive charge, but they are withheld inside the nucleus with a strong nuclear force which is charge independent and also at the same time very strong. But at times the number of protons and number of neutrons are much higher in number, so that maybe neutrons will be higher compared to proton or the reverse. At the time, this nuclear force won't be much enough or much stronger to hold on them. So what happens is that nucleus becomes unstable. So the binding energy of the nucleus may not be able to put it together. So at that time, the unstable nucleus has to be stable. So it takes some method for that. That means it is giving out some kind of decay so that it becomes stable. So this process is known as radioactivity or radioactive decay. So radioactivity was a nuclear phenomenon in which an unstable nucleus undergo a decay and finally becomes stable. So this was explained by the scientist A.H. Becquerel in the year 1896. And he mentioned that this nucleus, which is consisting of neutron and proton, undergoes decay in three different manners. One is alpha radiation, which means it is a pair of proton and a pair of neutron. This entity is known as alpha radiation or He24, helium He24. And another option is beta radiation. In beta radiation, it can have of two manners. One is beta negative decay and the other one is beta positive decay. Beta negative decay happens when you have too many neutrons. Neutrons by certain rearrangement gets converted to protons, and along with that electrons getting ejected. That is known as beta negative decay. Whereas in beta positive decay, what is happening? Too many protons are there. Protons are to be converted to neutrons, and along with that positron is getting ejected. The positron has same mass of electron but opposite to the charge of the electron. That is positron. And finally you have gamma radiation. In gamma radiation, we know that is exactly a photon itself, whose energy of the order of MeV or more will be emitted or absorbed. You have studied in Bohr postulate that if a transition electron from one level to other level takes, there is a chance for either absorption or emission of the radiations. So that kind of energy is known as gamma radiation, which is a part of electromagnetic spectrum. Clear? So these are the three means by which you can have radioactive decay. Now, an important law regarding law of radioactive decay is rate of disintegration of an atom is directly proportional to the number of atoms present at that time. That time means what is the time when the disintegration is happening. That particular time, take the number of atoms present, both are proportional. For example, at T time, let n be the number of atoms present. The rate of decay dN by dt is proportional to that number of atoms present at that time t. And the minus sign emphasizes it is disintegration process. Disintegration process meaning atoms are always coming down as time advances. Always it is a decay process. So to confirm it is decay, you will have a minus sign. Proportionality changed by the constant known as decay constant or disintegration constant with a minus sign already here. Then rearranging dN by n equal to minus lambda dt, where lambda is decay constant or disintegration constant. Now taking integration on both sides, LHS will be log e to the base n, RHS will be minus lambda t plus c, which is the constant of integration. To get the value of c, we assume at t is equal to 0, means initially let n0 be the number of atoms present. So substituting in this equation, we will have put t is equal to 0, n equal to n0. You will get c as log e to the base n0. And substitute here, log e to n is equal to minus lambda t log e to the base n0. n0 coming to LHS, log e to the base n minus log e to the base n0 is minus lambda t. And log a by b, log a minus log b is log a by b. N by n0 is minus lambda t. Taking the antilog, n by n0 equal to e to the power minus lambda t, or n equal to n0 e to the power minus lambda t. This is the mathematical form or the equation form of the decay law. Finally, one more thing, what is half-life period? Half-life period means the time after which the number of atoms left will be half of the initial number. For example, if 100 atoms are there when you started disintegration, after t half it reduces to exactly 50, or 50 has disintegrated, the remaining will be 50. That time is known as half-life period. So by that t half, when t equal to t half, it is represented by t half. So at t half, n becomes n0 by 2. Substituting in this equation, n0 by 2 equal to n0 e to the power minus lambda t half. n0 cancels, half equal to 1 by e to the power lambda t half. As you take lambda underneath, it becomes plus 2 equal to e to the power lambda t half. Taking both sides logarithm, this is log e to the base 2, lambda t half log e to the base same base. Log anything to the same base is 1. So log e to the base 2 is 0.693 lambda t half. So finally we will have the equation t half is equal to 0.693 by lambda. So we have discussed 3 topics here. What do you mean by radioactive decay? Secondly, what is radioactive decay law? And finally, t half. Hope it is clear for you. Thank you for watching. Thank you.